Good afternoon, everybody. Thank you for coming to class today. Thank you for watching, whether you're watching live or you're watching the recording. I just appreciate the fact that you are watching. Thank you for coming. So I was sitting here, right, like making sure I had all my notes, making sure I had everything together to teach this afternoon, getting amped up, getting excited. And then I realized that I hadn't made the link yet, nor had I sent it out. It had just completely slipped my mind. My apologies for that. Been just a little bit behind here lately, but that's all right. We're going to get caught up. And everything will be okay. So today, we're finishing talking about dictionaries. And we're going to do a lot of that via writing a program, right? Which is good, which is what we want to do. Right? So as we're getting started with that, just a reminder that you don't have anything that's due today. It'll be due next Thursday, your assignments from this module. Going to try to get caught up in grading today and tomorrow. Just a little bit behind there, but we'll be all right. So we're going to finish up talking about dictionaries today. Last time we were talking here, we talked about how we could create a dictionary and identify different things in a dictionary. We defined what dictionaries were, so just as a quick review, right, we said that a dictionary stores a mapping between two different pieces of data. So if we think about it like our lists from the module before, or our variables that we've been learning about since the beginning of time, we can kind of think about all of these data structures as being part of the same family, which, I mean, they are part of the same family. They're part of the data structure family. They're all data structures. And they're just different ways of holding and storing our data. And, we talked about a list in the previous module, and we said that we can address a list by index location. So if we wanted to address the third item in a list, we would look at the second index location. But instead of just being general, a dictionary comes from when we could use a more specific identifier, a key, to be able to interact with our data. And so we can think about a dictionary as a data structure, which is similar to a list, but instead of accessing the items in it by the index location, we access the items in it by the key. And the key in a dictionary, one of the things that we said last week, is very special. Right? A key can be any primitive type, anything that's basically immutable, because a key is immutable. And, we said last week, we kind of gave it the analogy of like the house and working with a house or something like that, where like if your key had the potential of one day accidentally changing and then you couldn't get into your house anymore, that would be a huge problem. Right? So the key is the way that we access the different items in our dictionary. So we want to make sure that we can't change the key. So the key can be many different types of data, as long as that data is unchanging, as long as that data is remaining constant. So just to kind of remind ourselves of the big important things here that we want to know about when we are learning about dictionaries is that, one, a key is unique, or a key must be unique, right? We want to make sure that we have a different key for every item in our dictionary, just like a different key would open every lock. Right? If you had one key that would open every lock, that's not very good, right? Like you want to have a specific association between your key and the data value that belongs to that key. If we assign a value to an existing key, then that will change the value that belongs to that key. And dictionaries are unordered. We can add any item in any location. The only difference being that, it doesn't really matter what you're looking for because the key is what gets you to the item, not an index location or something like that. Right? And that was something that fascinated me. I actually took a virtual tour of an Amazon warehouse last summer. Got the opportunity to do that. One of the things that they talked about was relevant to dictionaries here because they asked the people in attendance, they asked them, well, how do you think we store things? How do you think we arrange things for storage at the Amazon warehouse? And when you think about it, how would they do storage at the Amazon warehouse? I mean, you have thousands, if not tens of thousands, if not hundreds of thousands of products at the warehouse. If you stored them in a particular order, then that might require you to move 1, 2, a dozen, 50, however many items to another place in order to get what you want in a particular place. So they basically told us that we just throw them on a shelf. We just throw everything on a shelf. We just have to scan a key that's on that shelf before we put the items in that shelf. So there's no particular order in an Amazon warehouse, just like there's no particular order here in a dictionary. We just have to have access to that key. And then it knows in the system where the different items are in relation to the different keys. And so the little robots can go get the shelf that's in that location and bring them back. Right? Because everything's automated. We're not talking about humans here. It's a robot that's going to find that shelf, and they pick up the entire shelf, actually, and bring it back to the person that's doing the picking and packing. And actually, another little robot with a little flashlight end effector on it actually will shine a light on the part of the shelf where that item is located, so they can just reach over, see the light, reach over, grab something, put it in the box. The levels of automation to which the Amazon warehouse runs is absolutely incredible, right? We can see things like this that kind of give us a microcosm of how these sort of things work. Right? We're kind of thinking about it. We're thinking about it here on a small level with a data structure, but we could also just as easily think about it in a huge sort of structure like that with an Amazon warehouse. And so for our program today, our item that we'll be kind of going back and forth to a lot over the course of our time together this afternoon is going to be an employee ID program. Right? So imagine, if you will, that you are working at a facility. Right? You're working at a facility. And this facility hires people, and it gives each employee, when they come in, a unique user ID. They might tie that to a badge, so they could put that into an RFID, like a RFID or some sort of proximity system to where, like, if you badge into a room, then it would register your ID number. Or, everybody has an ID number. You have an ID number as a student at Cleveland Community College, right? It's a unique identifier of an employee, of a student, of whomever. So what if we wanted to write a program that would keep track of these user IDs, right? And maybe create a new one if we needed a new one or whatever. And so that's going to be the program that we go back and forth to today. And we're going to start out here by using it to just review a little bit about what we talked about dictionaries from last week. But in addition to talking about dictionaries last week, we also talked about global variables. And we talked about how important having a global variable might be in order to do specific things. And so in this instance, just like it was when we were working with our sort of proof of concept last week, our dictionary is going to serve as a global variable for us. So we are going to create our dictionary at the program level, and then as we write functions for each part of our dictionary, we will, or for each part of our dictionary processing program here, we will reference the global dictionary so that it makes all the changes to the same one. It knows which one we're using. And so we said, just like most other things, when we start to write a dictionary, it kind of looks like any other variable that we've worked with, right? We give it some sort of variable name, we put an equal sign, and that's where things change, right? Like if it was just a variable, we'd type some kind of variable value out here. If it was a list, we'd start with our square brackets. But since this is a dictionary, we add our curly braces. And I like to put a little line of separation here between the two, just so I can kind of have a nice organized dictionary here. And so our curly braces in this sort of way define the beginning and the end of our dictionary. And so from here, I can include some sort of key, right? The ones we used last week, I believe, were characters, were strings. This week, I'd like to use numbers, integers, right? Just remember that you can use anything that is non-immutable, or anything that is immutable. Right? Non-immutable is a weird way of saying something. Non-immutable would just be mutable. Right? Anything that's immutable. So our value here, our integer primitive here is immutable. And so we can just have a value, and then we put a colon and some sort of value. So we have our key, colon, a value. That's what we're seeing here, right? And at the end of that, we put a comma. So we separate our different dictionary entries with a comma. So remember that it is key, colon, value, and then we separate our dictionary entries with a comma. So let's make a couple other entries here. 102 will be Sarah. 103 will be Jeff. Right, 104 will be Rebecca. All right, after the last one, if we're not going to add another one after that, we don't have to put a comma after that. So I'm just going to have these four to start out with as the four people that are in our dictionary with employee ID numbers. So they have an employee ID number that is the key, and the value is the name of that individual. Right, and we're kind of looking at this on a microcosm level here, on a macrocosm. Right, this is the same sort of way that we would still deal with something, say in a database or in an associative array or dictionary like this. Right, we'd take the value that could potentially change in the future. Like if these were first and last names, right? Like someone might get married and their last name change. Right, so a name is not a permanent identifying characteristic. But in this instance, the ID number would be a permanent identifying piece of data there. So it would be what we would want to use as the key here, because that's never going to change. And oftentimes, like especially when we talk about databases and things of that nature, in a database, you end up with something called the primary key, and the primary key could typically be just made up. Could just be like a student ID or an employee ID that's going to be just a unique number or alphanumeric sequence for every single individual, because basically every single thing about personally identifiable information could either change or conflict with other people, right? There's more than one type, there's just like a couple standard entries for one of these personally identifiable information sort of fields. Right? You can move and your address changes. Something could happen where your name changes. Your telephone number might change. Things like gender or hair color or eye color or whatever, that comes from a limited set. So that's going to conflict with other users. Right? So in these instances, the only thing that you can be sure will be a completely unique and identifiable piece of information that will never change would be an employee ID number, right? And if this person gets terminated or retires, you don't reuse that number. They just remain a record in the system. So it never changes. And so let's start off with a little function here to just display our dictionary, and I'll introduce a new concept as well as we're doing this. So let's add our main gate here. So we can have that ready to go for us. And if we were to print users, here we'd see what we get by default, right? We get the entire dictionary formatted in that dictionary structure. Now, if we were to say print user of users, or for user of users would be the way that we would do it here. For user in users, print user. Right? And we said that when we do something like this, it gives us the key. Right? So when we're working with the in clause in our enhanced for loop here, and we say for user in users, it gives us the key. And if we were to wrap that key in square brackets after the name of the dictionary, so users square bracket user. So for users in user, the user is going to be the user ID. It's going to be the key for every record. So if we address users with the key that's going through, this is what's going to give us all the names. Now there is another way that we can work with this. And that's to use a built-in function that's already built in to Python, which is the items function. So let's change this up slightly. Let's say for item in users.items, print item. So dot items there, we see that items is a function. We know it's a function because it has parentheses after it. All right, so if we run this, we see what we end up here is a tuple for each item in items. or in the items, for each item in the dictionary. We have a tuple or set there for each of the records in our dictionary. So this is another way that we can actually pull specific things, right? For example, if I just wanted to pull names here, I could say for key/value, or for k comma v, whatever I wanted to do here, k being key, v being value. In items, print v. And so since I have these variables, these temporary iteration variables, structured in this sort of way, it's going to look for them in that sort of way in the tuple. So since I have two records in each tuple, the k is always going to be the first value or the key value. The v is always going to be the second value or the name value. And we end up with just the names. So this is another way that we can utilize this. And this is an easier way, in my opinion, that we can kind of print out and work with both the key and the value in the dictionary at the same time. Right? So if I wanted to write something that would print out my dictionary, let's write a new function here. We'll call this def print underscore dictionary. Put our curly braces in here. We want to reference that we are using the global users variable. And if we wanted to just print out a list of everybody that's in our dictionary, I can run a print statement here, or we can basically do what we just did, right? So for k comma v, or key comma value, or x comma y, or 1 comma 2, whatever, in users dot items, we'll print. Let's get a little fun with it. Let's put some kind of emoji in there. Briefcase emoji. Space. Then we'll concatenate that with the string value of, or the str, typecast value of k. We'll concatenate that with the colon, and concatenate that with the value of v. And that'll just kind of pretty print our dictionary in a way that is going to be easy to read. We could even go so far as adding another print line in here that would be like print. We put a couple spaces in here, key. Or we could put in like user, or it would be like UID or EID. And then name. Right, so we can even have it kind of structured that way. And we could print another line here for like employee IDs. So if we were to run that now, oh, I need to actually call my function. Getting ahead of myself. Print underscore dictionary. So if we were to run that here, we see what we end up with. We see it looks like we could probably add a space here, remove a space here, and end up with a nicely little formatted list there with our employee ID and our name. Right, so we have something that's pretty easy to work with now. And since we put this in a function, We can reuse this function as a part of other functions. Or, basically whatever we want to do. Right, and so something that's interesting here, something that I like to do, is I like to do this with a little sort of like, what would I call it? A little user prompt to get them to different parts of the program to start with. Right, so if they want to add an employee, you can press A to add, and then it'll give you the add function, or B to whatever, and it'll do that function. So we're going to do that here. But we're going to start off with just doing one function here, and then we'll put everything behind the logic. So we'll start doing everything one function at a time, right? Which is the way I recommend doing it, is just kind of one function at a time. And then we can build the logic to access the different parts, right? So if I wanted to build a function that would look up an employee, I might create a function. We'll say def employee lookup. And if I wanted to look up at a specific employee number, I might, take the EID in, use the global users dictionary, and simply return out users EID. Right, because that'll get me. So if I'm like, who has user ID number 103, right, or whatever. Maybe I'm looking at room logs and I see that, employee number 103 accessed this room at this time. Who's employee number 103? I could just do an employee lookup, and then it would return back the name. So I might want to run, say, a print statement that would take employee lookup and pass some kind of ID value in there, or pass some kind of, we'll say, choice value in there for today. So we need to actually get a choice. So we're going to start with choice equals input enter user ID. And choice here will actually be int choice, because our keys here are integers. So we'll want to convert that to a number before we do anything else with it. So just for the sake of output space, let's comment out that print dictionary line here, and let's give this a little run now. So we've gone in, we've looked at our security logs. We saw, employee number 103, they accessed the lab after hours. Who is employee number 103? 103. Oh, that's Jeff. So we need to call Jeff into the office and have a little talk with Jeff, figure out why they were in the lab after hours there. We can also do something the other way if we wanted to. So we could do something that was like an ID lookup. So let's create a def ID lookup. And we'll have to get a name value for that. So there are other, more, say, efficient ways that we would want to do this. Right, well, one of the ways that we can kind of do it based on what we know so far is, well, we're going to bring in our global users. And we're going to say for user of users, if, and that's not of, that's in. I've been writing a lot of JavaScript over the last couple of days. Your enhanced for loop in JavaScript is of and not in, like it is in Python. Just so you all know that as well. If users user equals name, return user. And then otherwise we can return not found. Right? So if it finds the name, once it hits that return statement, it stops, so we can take advantage of that fact. So if it just keeps going through and it does that and it never finds the user, then it'll just return not found. If we were to deal with choice with that, let's change that to name there, just so we can have that bit of context, right? So we're building these different functions up to be a part of our bigger program. And as we're building these different functions up, later on we can use logic to decide, which one we're going to use at what time, right? So we're going to print ID lookup. And maybe Sarah wants to know what her ID number is. So instead of going through the dictionary and looking through it ourselves, because, in this case, it's only 4 people, but it could be 100 people. We're going to run that. And actually, I got ahead of myself. That should be choice, not Sarah. So we're going to enter our username. In this case, it's going to be Sarah. And it tells me that Sarah's employee ID number is 102. Right, so now we have 2 different functions that give us multiple different ways to use our directory. We also have something that just allows us to print our dictionary in a pretty fashion. And that's just kind of based, we just kind of built that up over what we kind of learned last week, right? And so all we really have left to work on this week is additions and removals, if we want to remove something from a dictionary or we want to add something to a dictionary. And of the two, right, adding to a dictionary is more intuitive. So that's where we'll go to next. I mean, really, they're both kind of easy, right? So to add to a dictionary, if we have a brand new key, then that new key will allow us to get the value, or will allow us to set a new dictionary. So if we just try to add a new key to an existing dictionary, it doesn't have a key to replace, so it's just going to add it to the dictionary. And we see here we use the del keyword to delete an item from the dictionary and delete it using the key. So we'll go back and we'll look at that a little bit more in just a moment. But let's play with an add function here, and I want to add a little bit of functionality to this that'll be a little bit different. We'll kind of take some stuff from the last module and we'll bring it into this as well, because it's something that's going to be kind of easy for us. Right, so see here, we want to make sure that not found value stays up there with that function. And let's create a function. We'll call this add user. And there are a couple ways that we can handle this, right? We can handle this by just having the person put in a number. And check to see if that number already exists in our dictionary. But it would be smarter if we wanted to add a user if we didn't give them the option to mess that up, right? Because one of the things that we've said before is that, if we reassign a value to an existing key, then it's going to mess our dictionary up, right? It's going to change the value that belongs to one of those keys. So if I want to add a user, one of the things that I want to do is I want to make sure that I'm using a number that hasn't been used yet. So let's play with this for a minute. And let's use our global users here. And let's do something that we talked about in the last module. So we can kind of bridge this module and the last module. And let's take the users, all of the users, and put them in a list. So let's create a list here. We'll call it IDs and set it to an empty list. Right? Not the most efficient way to do this, but for where we're at as beginners, it's a good way for us to kind of take this task on. And we'll say for user and users, IDs.append user. And so that'll give us a list of users. So if we were to print IDs here, and then run this function, let's run add user. We'll see what we end up with. All right, we just end up with a list of users, and we can operate under the assumption that everything in here is going to be, all of our keys are going to be unique because all of our keys are supposed to be unique. We could use an empty set here if we wanted to be guaranteed of that, which in order to do that, I would actually have to, for the way we're trying to set it up here, I would actually have to take the IDs here and convert that to a set, typecast that to a set. And that would ensure that they are all unique, but you can see here it kind of messes with them a little bit. Right? They're not quite in the same order there. That's based on how Python handles sets. But if I took and say max function on IDs here, then that's going to return the highest value. So if we had a variable here and we call it new ID and we set it equal to max IDs plus 1, then we could take global, assign it or take users, which is our global variable. One moment. Sorry about that. If we take our users global dictionary here and give it the new ID key, then we know if we're going to add a user, we're going to always add a user. And we're going to set that equal to the input of enter name of new user. And then we can just print dictionary to see that in effect. And let's go ahead and let's add an empty print statement here so it puts a line between, a blank line between this input and the output. So this will automatically find the biggest number that already exists in my keys, add 1 to it, and make that the new key. So we can always be guaranteed that our key is going to be new and unique. Right? It's a smart way of doing things. So we're running add user here, so we can do that. So already in the background, it's searched through my list. Found my new user. And so if I say, okay, well, Sean is a new employee, we can see that it automatically goes through, gets to 105. 105 becomes new user's new ID here. Taking the name Sean. Since the key here is brand new, it adds it to the list, and we just have 105 Sean here. Now, since we're not using any persistent storage, all of this is on volatile storage versus non-volatile storage. Non-volatile storage is what the next module is for. Then once we hit run again, it'll wipe that back out to 0 and do all that kind of stuff. But maybe we could, if we put this in a loop, for example, we could see it work even better. So we could say something like for I in range 0, 4, just so we can do this a few times. This will do it 4 times. 0, 1, 2, 3, and then up to but not including 4. We can add a user here. And so we can say, oh, Sean is the next user. Then David is the next user. Then Nancy is the next user. Then Rachel is the next user. And so we can see automatically it adds 1 to the highest value. That becomes the new key. We put the name in there, right? We just have a rolling dictionary of employees with employee IDs there, which is pretty cool. Right? So we see Sean becomes 105, David 106, Nancy 107, Rachel 108. So if we want to delete a user from the dictionary, one of the things that we saw there from our last slide is that we can actually delete a user using our del keyword there. So let's add a function here to delete our user. This will be def. We'll call this delete user. We would want to get the user ID. So let's create a EID or UID variable, employee ID or user ID variable, and set that equal to the input of enter user ID. And then we could just del users at the int EID value. And then just print out the dictionary to confirm. Print dictionary. So let's say we added somebody by mistake here, or we got something wrong there. Right, one of the things that we would want to do here we can run our delete user function. Let's say we want to delete Jeff from our user database. So we can delete 103. And we can see Jeff is now gone. The other thing that we might want to do here would be a name change function, right? So we can create a def name change. And we basically just do the same thing here. We'd have the employee ID. So we could enter the user ID, a name equaling the input of enter name. And then we would just set the value of users. And that is something that we didn't do here, just to keep it. We need to import that users. I mean, as we talked about last week, it's not a requirement, but it does help keep things nice and clean and gives you a good understanding of what it means. So it's both for you and the interpreter. But we can do users int EID now equals name. So in this case, let's say Sarah. We spelled her name wrong. It's Sarah with an H, and it was supposed to be Sarah without an H. So if we ran our name change function here, and let's stop. We're going to want to actually print our dictionary here so we can actually see the change that was made. So the employee ID is 102. The new name is Sarah with no H. And now we can see that updates it to Sarah without an H. Right, and so those are our big functions, right? I mean, we've basically created what we would call a CRUD application here, right? CRUD, create, remove, or create. R, what is R? UND is update and delete. Either way. We can add people, we can change them, we can update their name, we can delete them. You know, we can do, the basic functions that you'd want to do here. And so from here, we can actually create some logic to determine when we're going to run functions at what time. Right, and so what I'm actually going to do here is I'm going to put this inside of, if you were a game programmer, you'd call it a game loop, just a persistent loop. So we'll say while true, and the first thing we'll do is we'll get choice. And choice will now be, what do you want to do? And some of the things that we can do here is we can add our escape new line characters to break this on new lines. So we could say enter ID for name. And this is all supposed to be an input, by the way. We're going to have to put input here. Enter ID for lookup. And we were doing enter ID for name, lookup, escape new line, enter name for ID, lookup, escape new line, enter A to add, enter D to delete. And then we want something to end it, right? So enter S to stop. All right, so we're giving our user a whole bunch of choices here in terms of what they want to do. All right, so if we were to see this in our console, it would look like this. Did I do the wrong? I sure did. I did the wrong character for escape there. Getting late in the day. Right, so we end up with something like this to where, you know, everything's on a different line. We might even want to add a your choice like this. So we can see it like that. Enter ID for name lookup, enter name for ID lookup, enter A to add user, enter D to delete, enter S to stop. So the first things that we would want to do here, we would want to do, since they are definitive choices, we would want to do A, D, and S. Right, so let's start with if choice equals S. Well, that's going to be easy. That's just going to be a break statement. Elif choice equals A. Well, in that case, we're going to run our add user function. And I did forget the update, didn't I? Let's add a I know all of these statements are outside of the loop. We need to tab in. Good catch, IDE. And we'll add a enter U to update user. Okay. So A will add a user. Elif choice equals U. We will update. What do we call it? We call it name change. Yeah, we'll enter a name change. Elif choice equals ID. We'll run our delete user function. And then what we would have would go into, if we're going to do name or ID, it would go into an else condition, because that can be anything, right? So before we do that, let's test something out here. What happens if we try to get an integer typecast value of a string character like A? We get an invalid literal. So this is actually a good opportunity to try out a try except block in a program, right? So we can write an else statement here. Inside of that else statement, we can add a try. And so we can try to do a certain thing. So in this case, we can say user input equals int choice. And so if that works, we want it to go on to run the lookup for the ID. So this will be employee lookup user input. If that doesn't work, if that throws an exception, we're going to run our other function, and that should be an except instead of an else there, just muscle memory, for ID lookup. So except ID lookup choice. And so that should be the logic that we need to do everything that we have in our program here. So if we want to add a user, we'd enter A. We'd enter the name of our new user, right? It's getting the key in the background because we did that already. We'd enter in, say, Sam. And we get that printed out for us to show us that Sam is in there. If we wanted to update a user, maybe Sam is short for Samantha, so they'd want that instead. If we want to delete a user, maybe that was done by accident, or maybe we could do 103 to get rid of Jeff. We could do that as well. If we entered in a user ID, it didn't do the thing. Let's see here. I think what I might want to do is put this actually over here. Let's try something else here. Let's try typing in Peter. And so my try except here isn't working. This was something that I added on the fly, so let's try to fix it. Let's try to add our user input here instead. And then make that the try except. I don't think that's how try except works, but we'll give it a shot. No, of course not. Oh, shoot, it was right. Because I'm using return statements out of those functions instead of print statements. So I need to put that in a print statement. That's what my error was. Some of you might have caught that. If you did, you did better than me at 3:30 in the afternoon. So now if I enter in Peter, yep, it gives me 101. Perfect. And if I enter in 103, it gives me Jeff. And if I enter in S, it stops my program. So that does basically everything that we would want to do in general in a dictionary in one singular program. And so you'll get this when I send out the recording. Right? Because there's a lot of code here. I'm sure you'll want to get all of your eyes on it. But that basically gets us everything we want to have about dictionaries here. You know, we kind of have dictionaries wrapped up in a nutshell there. So that's where we'll stop for today. Remember, nothing due today. Your dictionary assignments are due next week. If anybody who's here with me live has any questions, we'll take those now. Otherwise, we'll start wrapping up. Fun little program here. Gets us a lot of options of things to do with our dictionary. With some good logic. Like if we wanted to, right, one of the things that we could do is have it kind of print an empty line down here at the bottom as well. So just like after everything, it's going to have an empty line. So if we added a user, it'll put an empty line there after it prints out out the dictionary. If we updated a user, it'd do that. If we deleted a user, we could have that. We do our update, we do our lookup. Both ways. One thing you might want to add is a little bit of logic to those lookup functions, to where if it's not in there, like we'd add an else statement here basically that just says, or we already did that because we're returning not found if the ID is not found. But I don't think we did that for the name. Yeah, no, we're not doing that for the name. So that might be some logic that we wanted to add there. You know, if the ID is not found, like if we, it's going to give me a not found, but we didn't add that logic for the regular for that employee lookup, or for the name lookup, or we did. We did. I guess it's working fine. Yeah, because in that, actually, we were a little smarter than I think we thought there. Not sure. Anyway, it's fine. Might want to play with it yourself and try to add some logic in there if there's anything that's missing. So no questions that I'm seeing coming through in the live chat today, so we'll go ahead and wrap up from here. If you think of a question later, or you have something come up, or if you're watching the recording and you think of a question, feel free to send me an email or a Teams message and we'll get that squared away for you. But that's all that I have for you for today. Thank you for watching. We'll see you next time.